So we've identified that the first point on that one shows $25,000 worth of sales. The second point shows $24,500 worth of sales. The next one shows how much? $22,000 worth of sales. And the last one shows $21,000. Okay, so in the first year, only went down how much? $500. Yes, Cam?
With it not starting at 0, when it went down to 21,000, it looked closer to the bottom of the graph.
It does, doesn't it? Yeah, it looks like it's almost down to no sales at all. But it's really, there's still how many dollars worth of sales? $21,000 worth of sales, and it looks like it's getting really close to $0 worth of sales with it not starting at 0. So that's a good observation also. And then here it looks like it dropped quite a bit. So if they want to say, you know what? Look at in the middle there, it dropped $2,500. Did it really drop $2,500 a year? No, because that's a 2-year period, isn't it? So how much did it drop in that year, each year? $1,250 each year. So this is that when they did not start at 0, it is exaggerating the decrease when it really wasn't that much. $1,000 a year rather than what it looks like it is. And notice then when it's corrected how you can see that, you know what, it really didn't decrease much at all in the first year. And then as you go down, so we could actually put another point like right here. We could show it's not really decreasing all that rapidly. It is decreasing though still. Okay. How about circle graphs? How do we know when a circle graph is misleading?
If the numbers don't
Right?
add up.
Thank you for raising your hand.
If the numbers don't add up to 0. I mean, no, if the numbers don't add up to 100.
Yeah, numbers don't add up to 100. Because what does a circle graph show?
It shows the percentage.
It shows percentages
100%.
and of a whole, so 100%. It has to show 100% of what's going on. So when you look at that first one where it's the favorite school club, you look at that one and you say, which school club do you think created this misleading graph?
Favorite school club, the first one.
Which one? But who? Which favorite school club actually wanted to use this graph? Probably the what? Which one?
The computers.
Okay, possibly the computer, and because they want to look like they are the most popular, right? And when you look at that graph really quickly, if I were making a presentation to you and saying, oh, you know what, you all should join the computer club, it's like almost 50% everybody the favorite. I think almost half of the students like computer club. You all need to get on board. You all need to join. Would you want to argue with me?
No.
Is it almost 50%?
No.
No.
Like the graph appears? Because it fills almost half of the circle, doesn't it?
Yeah.
It appears to be almost 50%, but it's really only what? 38%. About what? About instead of half of the kids are in computer club. About how many actually are? About 3/4. Okay, here's the real one. Here's the real one that's good. They all add up to 100%. About how many of them really are?
1/3.
1/3. About a third of them are. Not a half third. A big difference between a third and a half.
Yes.
Yeah. If I have $1 million and I'm willing to give you a half of it versus a third of it, which one do you want?
Third.
You want a third. Okay, good. Okay, let's go do some practicing here on our own. The graph shows the number of men and women who have enrolled in a school. Explain why the graph is misleading.
Because you don't start at 0.
So everybody study that graph on your own. Study that graph. It's a double bar graph. Why is it misleading? And then when you're ready to offer an answer, just raise your hand and I'll be happy to call on you. Right?
The graph doesn't start at 0.
Okay. We got to be more specific than that. Which part of the graph does not start at 0?
The students. That's
The number of
men and women.
So could we just, how about, could we also just say maybe this way we could say the vertical scale does not start at 0?
The
Good, that was, is this the vertical? Is that the one you're talking about, is the vertical? The number of men, the number of women? Okay, because we could write a little bit shorter that way. The vertical scale, what we call the y-axis on a coordinate plane, does not start at 0. End of sentence. But also, we probably better check the horizontal axis. Is the horizontal axis kosher? Is everything cool there?
Yes.
Yeah. What's the question?
No, I was gonna say,
You want to move on?
yeah.
Okay, could you just hold on for a second? Are we saying the horizontal axis is okay then? Goes from 2000 to 2001 to 2002 to 2003. Everything okay there?
Yeah.
Okay. Well, in this one, we don't really. It's not a histogram. It's a bar graph, so we don't really have to worry about whether it jumps over some on this one. Okay, that one we don't have to worry about. What might someone believe because of the graph?
That 2000 has.
Everybody make a decision here. What do you think someone, you look at this graph or someone else does, that's sitting next to you at a presentation and they're like, oh, wow. What do you think someone might do? This is where you need to make intelligent statements in your homework, people. Okay, you gotta show me you have a brain. No? Well, sometimes there's more men than there are women, and other times there's more women than there are men. So maybe we should try to, go think of something else that we could show. Because, yeah, that is what's happening. Sometimes there's more men enrolled than there are women, and vice versa. But what does this graph make it look like? Smarty, do you think you have something?
In 2000,
There are more men in 2000. It's tough to kind of come up with this. Right? Did you have something? You forgot it. Stefan?
One day I think when in like the year 2000, 2001, 2003, they always started with 145.
So in 2003, you said is that the one you're referring
Well,
to?
I'm older.
Oh, okay.
Like they start like I said, 2000, for example, they started with 145 million.
Yeah.
And they went up to 152. And in 2001, they dropped again from 152 to 156 maybe.
Okay. So, so the bars, they're in 2000, the bars are a ways apart, but not like a huge ways apart. How about in 2001? Are the bars, is there a big difference between their heights? Yeah. And how about in 2002? Not so much again. 2003, there's a fair amount.
What is
So-
wrong with 2003's bar?
What's wrong with it?
Like it's like on our paper, there's like a little rectangle. That's what I was gonna ask you earlier.
You just can't see
The white.
You just can't see the white.
One line is top.
Define this. Just draw this around. This is the bar for the women on that one, okay? It goes up to 146. Just draw the line harder, okay? So I think this is what you're saying is you don't understand.
Yeah, he knows where it's at.
Okay. Okay. Here's what we really should be seeing. Okay, I even have to do this. I'm gonna. The way the graph is made, it looks like there's quite a difference between the number of men and the number of women enrolled. In other words, there's gender inequity at this particular school. Okay, there's maybe there's a difference between there's a fairly good difference between how many men and how many women are enrolled at this school given a year. So let's just write down. Someone might believe there are bigger differences between number of men and women enrolled. Hope you're not ready as big as I am because I'm running out picture am I making sense here? Someone might believe there are bigger differences between number of men and women enrolled than there are. Differences, so I'm gonna use plural are. Okay, someone might believe there are bigger differences between, I should probably have a thought there, the number of men and women enrolled than there are. Then who might want to use this graph, right? This college, do you think this college wants to?
No, just a college that wants to,
So maybe another college,
a college that
headed-
wants to appeal to like maybe sports, like a college that people want to play, like, I don't even know.
Yeah, it doesn't really have to do with sports, but we could kind of show that this would be someone who wants to show inequity exists. Someone who wants to show that inequity, which is such a big deal in colleges, especially with sports, at this school. Someone who wants to show that inequity exists at this school. When in reality, what was the difference between men and women enrolled in the year 2000? Yeah, but what was the difference? What was the actual difference? Two people. What was the actual difference in 2001? 4 people. 4. What was it in 2002? Only 1. And in 2003? 2. Is there inequity at this school?
No.
No. But when you take a first glance at that graph, you would say, hey, wait a minute, how come there were so many more men than there were women in 2000? Why were there, oh wow, what happened? There were so many more women in the year 2001 than there were men. But in reality, there were only 4 more women than there were men. So this is not as drastic as it looks. Anybody have any questions about being able to try? You need to try really hard for me to be able to make good statements. Okay, let's go to the back side. This is one of those things that it's really important that we make sure we don't just accept information that's given to us and we scrutinize it and say, wait a minute, did you really sample the right people? Or did you really sample enough people? Or, that sort of thing. So, I'm just going to read for this one. Here's where I'm at. I want you to take a quick look at this one. A researcher surveys kindergartners and asks them, this would be, so you guys are complaining about homework at Valley City High School. So a researcher says, okay, I'll ask some kindergartners if they have too much homework. Explain the following statement, why it's misleading. Only 5% of the students at, I'm going to say Valley City Public School District, think they have too much homework. What's wrong with that? Kindergartners don't have much homework, do they? So if you're only going to survey kindergartners, what are they going to say?
You're going to say whatever.
Yeah, they're going to say, no, I get to play outside after school, I don't have any homework, But you guys are saying, wait a minute, you should see how much we have. How come nobody asked us? So that's a biased sample because they only asked the kindergartners. They're not the only ones in the school district, are they? Okay? Then another one here says, a researcher asked 2 people whether they approve of the way their town is, what's going on here, is being run. 2 people. So you go to Valley City, and they say, okay, well, we'll pick somebody on this side of Central Avenue over there, and we'll talk to somebody over on this side of Central Avenue, and we're going to ask them, do you like how our town is being run? And one of them says yes, the other says no. So now they put it in the Times record that, you know what? 50% of the townspeople are unhappy with the local government. Would that be true?
No, because they only interviewed 2 people.
They'll interview 2 people.
A large population.
Yeah. You know what? I don't care how small the town is. Would 2 people be a fair sample?
No.
No, it wouldn't be a fair sample at all. Okay, and then our last one, a car dealership is selling 5 cars at the following prices: $12,000, $13,000, $15,000, $55,000, and $13,000. Explain why the following statement made by a competitor is misleading. The car dealership sells cars at an average price of $21,600. Average, that's the mean, right?
That's not the actual average.
Why?
It's just not.
It is too. They added all 5 numbers together. Go ahead and try it. They added all 5 numbers together. They divided by 5 and they got 21,600. Josh? Yeah, the $55,000 increased the mean, didn't it? That's what do we call that number? An outlier. That outlier increased the mean. So in reality, the competitor's using that one so that they want the mean to be higher. They want to say, hey, come buy cars from us. Our average car sells for much lower than that. Okay? Okay, let's look at number 2 here. Houses on Main Street sold for the following amounts: $175,000, $182,000, $178,000, and $389,000. Why is it wrong? Why is it misleading for somebody to say, you know what, the houses on Main Street are selling for an average of $231,000, right?
Because they threw in an outlier of 389,000.
Yeah, $389,000 is an outlier. So what did that do to the mean? It raised it up. So we're going to say 389,000 is an outlier which raised the mean. In fact, if the mean, they say, is $231,000, how many houses even sold for that much or more? Just the outlier, right? All the other 3 sold for less than $231,000. All of the other 3, the majority of them sold for less than that, so that $389,000. But you know what? If somebody wants to convince you that you should sell your house, they might use this misleading information to convince you to do it. Okay, number 3, a researcher is contacting people by email to see what proportion of them use a computer every day. Explain why the following statement is misleading. 85% of people use a computer every day. This is what they found out. They found out that 85% of people use a computer every day, and they contacted a bunch of people by email. What's the problem with that?
You
Cam?
contact.
Just because you answer one email doesn't mean you're on it every day.
Okay, so does everybody, just because you have a computer, does that mean everybody uses email? No, I got some parents, I try to email them and they don't, I never hear back from them. You know, I gotta learn to call them. Yeah, so just because you have a computer does not mean, so we're gonna say the sample is biased. That's what we call a biased sample. The sample is biased. And we're gonna say it's biased because people who do not have email or don't, we'll say they don't have email or don't use it. We'll say use email, makes more sense. People who do not use email weren't surveyed. They weren't included. And the question wasn't, how often do you use email? The question was, how often do you use a computer every day? There are some people who use a computer every day and never get on email. So those people needed to have a chance to be included in the sample. Okay, well this is a good one. A researcher asked 5 students if they think the cost of school lunches is too high. 4 of them say it is. Why is this misleading? 4/5 of all the students think school lunches are too expensive. Right?
Students don't always pay.
Well, what do you mean students don't always pay? Some of them go through the line and,
No, like, it's not their money.
oh, so their parents are paying,
Yes.
so they don't care how expensive it is. Well, that could be, you know, some of their, like maybe that, you know, one person who didn't respond that it's too expensive, that might be what they would say because their parents paid for it. Ariel? They only asked 5 students. Is that big enough sample size?
No.
We're going to say the sample size is too small. sample size is too small. In other words, you know what? If they wanted to know if your lunch hours should be extended here at Valley City High School, and they only asked 5 students, and they were 5 students who went out, who actually live across the street, you know, right in the neighborhood, and they went home for lunch, and they had plenty of time. Would you be happy about that they only sampled 5 students?
Nope.
No, you'd want them to sample quite a few more, wouldn't you? Okay, so which would be more trustworthy then, a survey of 10 people or a survey of 100?
100.
It seems like a no-brainer, doesn't it? Why is it 100?
Because then it's a outlier.
Yeah. The larger the sample size, the more trustworthy the results. End of sentence. And we're going to circle 100 people, not 10. Of course, you don't want to sample such a large size that you can't even begin to, talk to everybody, but you want to make sure that it's at least fair. You want to have a good representation of what we call the population. Okay? So here's your assignment, which is doing some of what we did in these notes, front and back of the notes. Make sure those are out to help you. Your book can also help you with this. It's the only day we're spending on it.